Buffer calculations for pH equals pKa plus log base 10, the conjugate base concentration over the weak acid concentration. Henderson-Hasselbalch equation. Here's the question. A buffer solution containing 0.1 mole per decimeter cube sodium ethanoate and 0.25 mole per decimeter cube ethanoic acid with pKa equals 4.76. A 0.05 mole per decimeter cube sodium hydroxide was added. Calculate the final pH and change in pH. From the question, we have the weak acid in large quantity because it's partially dissociate, so we got small portion of that and small portion of the base. We also have the sodium ethanoate here. That's a strong base, so it will dissociate completely into sodium plus and large quantity of the conjugate base, and that's because of complete dissociation. Finally, we got the buffer solution, weak acid ethanoic acid, and the large quantity of conjugate base, ethanoate. So first we're going to calculate the pH of the buffer, and that's why we've got the ethanoic acid here and the ethanoate. Here are the concentration of ethanoic acid and ethanoate. I'm using the equation from Henderson-Hasselbalch equation, and the pKa is given to us, and the log base 10, 0.1 for the base, and the 0.25 for the acid. We get pH equals 4.36. Here's the buffer with its pH. Now we need to calculate the final pH after adding sodium hydroxide. So we got the buffer solution, and then we add sodium hydroxide. So when we do the initial, we got the concentration of the weak acid and the conjugate base. Now the 0.05 of sodium hydroxide will react with the acid here to create more the base, conjugate base, and so we have to do minus 0.05 because this is the least compared to the 0.25. So the sodium hydroxide is the limiting reagent because it will be used up, and so we do minus 0.05, and we're making more of this, so that'll be plus 0.05. At equilibrium, we're going to take away 0.05 from 0.25 to get 0.20, and we add these two together, so we get 0.15, and this is 0. Applying the Henderson-Hasselbalch equation, and then we plug in the values. For the base, 0.15, for the weak acid, 0.2, and that gives pH equals to 4.76 minus 0.124938. Final pH is 4.64. We also need to find the change in pH, which is the final pH minus initial pH, and the final pH is 4.64 minus 4.36, and that equals to 0.28. So that's an increase in pH by 0.28. When we add the base, the change in pH is 0.28.